Okay, Assalamu alaikum, Bismillahirrahmanirrahim. So, as the brother said, my name is Farid. I actually started here my academic journey, and then I went out to do work and create my own sort of biotech industry. So I started at Cambridge, I started here. Actually, my labs were up there. I did my first degree in chemistry at the University of Salford. I did my second degree in biology, which was in parasitology. And then I went off from there to learn a secret knowledge, a Masonic knowledge. And that was to look, how do you find cures for diseases? Now, this knowledge was really in the hands of pharmaceutical companies. And you would screen many, many compounds. And then when you screen these compounds, you find this drug works for Alzheimer's or this drug works for malaria. And once you got that knowledge, I thought, hey, I'm going to quit my job and start a PhD. And then I did my PhD at Cambridge in biophysics. So chemistry, biology, and physics was all the sort of knowledge I was taught. But again, I come back to knowledge. Knowledge, as we said earlier, one of the brothers was saying, came from the Greeks in some ways, but they were theorists. And then you have the Muslims, particularly in Andalusia in Spain. We translated that knowledge, in other words, in practical sense. And now, if you look at the Muslims right now, what are we doing? We keep on saying, oh, listen, we did all of that thing in history, and we're proud of that. But actually, we need to do something now. And this is my journey, and this is something I'm going to share with you, inshallah. So, the title of the talk is Protein Technologies. And we are all machines. At the microscopic levels, we are built a little bit like metal, if you like. The component parts of how we are built are things called proteins. And those little machines generate ourselves and indeed propagate us. But what's our motivation? My motivation in particular is whoever saves one life, it is as if you've saved the whole of humanity. And this is important, because this is a driver, this is an instructions. Hey guys, yes, you can be a bank manager, you can be an accountant, you can be that, but this is the noblest of things. How about having that at the end of your life, and you said, wait, I saved one life, and I've saved humanity. And remember, Allah's going to ask us one day, what did you do with that knowledge? Not did you gain that knowledge, is what did you do with it that changed. So I'm in the area of innovation. When antibiotics was discovered and then manufactured by Sir Alexander Fleming, it was just by accident. He was playing around and he found, oh wow, look at this. This compound actually kills bacteria. And that was a revolution, and that saved millions and millions of lives. In fact, a lot of you won't be alive because of that. Without that discovery, you will not be alive. So antibiotics is just one example. But in innovation, you have a modification. Something's modified, changed. A bit like the PCs of the big world that you have, and then turned into the tablets that you have now. That's the innovation part. Then a revolution happens, and that becomes all interconnected. So today, there are several waves of innovation. The first wave was all about water, iron age. Then we had steam, which was the second revolution, and that was in the 18th century. Then we have electricity, we had chemicals, etc. Then we had the fourth wave, petrochemicals. We're in the fifth wave, which is about digital networks. The future is always going to be biology. How can we substitute human parts? How can we change the environment so it becomes much more sustainable? So the future is biology. Now, the classical example it was only in the 1950s and 60s that actually you simply got a pig, you put it in a blender, and then you had to extract the insulin from that pig and then inject it into those poor diabetic people. And that's the only way that you can manufacture at scale. So you have to have huge amounts of these liver spleens, etc., to extract from pigs themselves. What happened next was what Brother Sabu said. You can get the gene, the human gene of insulin, and put it into a bacterium, or you can put it into yeast, just like how you make bread, basically. You ferment it. And from there, you can make tons of this insulin, and it's called recombinant insulin. It's not from human beings, but it's exactly the same. And so that made us create and produce new medicines. And this is a revolution. So all of that knowledge is important in terms of how we create these new medicines. So proteins, like I said, are the machines of life. They're composed of these little beads, if you like. There's 20 of these beads. Life uses approximately 22 beads. And this then creates the structures. Those are the structures. So you get these beads that start folding together and create things like hemoglobin, which is bright red in your blood, and things like chlorophyll, which is green in plants. So these components are very important. My PhD was all about fluorescent proteins. Now you think, well, what are fluorescent proteins? Well, they fluoresce, they glow. Why is that important? Well, actually, about 8 years ago, there's a Nobel Prize given in this area. And fluorescent proteins allow you to look inside the architecture of cells, the architecture of life, and look at how things are dynamic, how things work. In fact, the machinery of cells, how we interact, how it works, how we reproduce. So this is very important science. So that's the structure of these things. If you highlight all these little things, you can see all the greens and yellows and blues, you can see exactly the traffic of life and how it works. So you can also do the same with these fluorescent proteins, with plants, and understand how they grow. This is interesting. This monkey here is called Andy. If you go and reverse the word Andy, it means iDNA, which is inserted DNA. Now, Andy was one of the first monkeys that lived, there was a gene implanted. This green fluorescent protein gene was inserted in its embryo, and this was the one which survived. So although this monkey wasn't fluorescent, in the genome, it still had that gene, the fluorescent gene in there. Why would you do that? What we're doing here, it's not what I do, but you are changing the code of a mammal here. Now, why would that be important? I'll explain to you in the next couple of slides why that could be important. But where do these fluorescent proteins come from? All these, so we go on gene hunting. So I'll explain what that is. So I go around the most tropical lands in the world, such as Malaysia. Malaysia's a particular place because it has a lot of these corals. And these are the type of corals. So I work with the Malaysian government, and we work on various programs, and I go around hunting for these corals, taking them out, taking their genes out, and then looking where I can get these different flavors or these different colors of fluorescent proteins, which will allow me to look at life and look at the molecular properties of life. So this is a signed, we did this big sign over in Malaysia recently in Sabah, and this is one of the most beautiful places on earth. This is a Muslim land that allows you to go inside, and I see things which, I have a lab on the beach. I have my students going around, Farid, we found out, what is it? I don't know. Let's find out what species it is. Does it glow? That's what I'm interested in. So this is me with a head of a large pharmaceutical company, a guy there, Hans-Peter. Those are some corals. Those are some of my dive teams. And so we go out and do all these exciting things. But the structure of that one molecule, that fluorescent protein, look how beautiful it is. I'm just going to go across here just to show you. It almost looks like a lantern. Look at that. It looks like a lantern, and in the middle, there's a filament. This is from nature. It's amazing. It's a beautiful structure. On top of that, if that colored protein changes color. It changes color if it's frozen. It changes color if it's heated. It changes color with time. When you first make it, it's colorless. Over time, it matures and ripens and turns into red. So you're measuring time. These materials you can't do with current synthetic probes. So nature has inspired us here. This is an interesting one. So remember I said there's only 20 amino acids, 20 beads that you could create these proteins with. So as part of one of my chapter in my PhD, I thought, well, forget 20, let's imagine if we had 100. What could we do with that? So this is actually Manchester's, one of Manchester's greatest innovations other than graphene that was displayed in Caen in France, showing a protein that we made in our laboratories. We call it GFP kryptonite. What we did, we inserted an unnatural amino acid, an unnatural one, a fluorinated one, which we published on, and created this fluorescent protein, which is normally quite bright, but we made it 10 times brighter. So by manipulating nature, we could do that. But why would we do that? And again, it's a bit like the fermentation technology I spoke to about, that revolution technology to make new medicines. Well, for example, if you make a medicine like insulin, then you don't have to inject, because what you do, you can swallow a pill using that unnatural methodology. And remember how we make these. We make these in bacteria, so we modify those. So it allows us to take a puff, so you don't have to stab yourself. So this gives new properties to proteins. So this is something quite remarkable that we can investigate. In particular, how we are killing cancer cells today. In 10 years' time, we'll look back and we think that's barbaric. It's like nuking, killing the cells indiscriminately. We're looking at ways to specifically target cancer cells as well. So we use probes. We use these fluorescent probes that has antibodies that can recognize not the healthy tissue, but the abhorrent tissue, and then it can go in, and then we send a pulse of light, because remember, those lamps, they can heat up, they can release drugs, etc. That can destroy specifically those cancers, so you don't have all that radiation type effects that you have. And this will also we're using in various other cancers as well. So this is one product that we have already in preclinical stage. This is another beautiful architecture for fluorescent protein. And look at the shapes of these things. These are atomic scale here. Look at how beautiful they are and how well organized they are. So we know we've injected this in animals. We know it's safe. We know we can trace it. We can also trace it in small printer type diagnostic kit. So you don't have to go to a massive MRI machine, which will cost millions. This is a very inexpensive way to diagnose cancer as well. So you could do this in GP surgeries. And indeed, we're doing sort of mice trials to make the efficacy of this product much better. So that was us. So we had this capability, this multi-million-pound laboratory, and how this came to pass was actually a bunch of my family and friends here in Manchester. One day, some of them are dentists, by the way, some of them are second generation. These are the next generation people who have a little bit of excess money. And I said, right, guys, I've got this laboratory. I managed to inherit a multi-million-pound laboratory from a large pharma. And I thought, well, we've got the kit. This is the first laboratory for humanity which Muslims are running in the world, I can tell you, even now. People have, you have various places, Muslim countries, etc. They have a hospital, they have a laboratory, but nobody's doing anything really with that. It's like an open source lab for us. So what we did, we raised in 1 week £300,000. We put people in, and it's a phenomenon, I can tell you. So other than, we've had lots of collaborations from Bill Gates to the Wellcome Trust and various others. This is a little story I'll tell you about. This is a friend of mine I met. Actually, I met his brother in Malaysia. And he said, Farid, my son, he suffers from a disease. It's a rare disease. 1 in 100,000 people get it. And the pharmaceutical companies aren't even interested. They're not going to make money on this. And they said, Farid, I know you're a crazy scientist. You could do what, you could do what, could you help my children? Because what they suffer from, these little boys, is that they urinate black urine. It's a mutation in their bodies for one enzyme. That mutation creates that black urine. But the black urine is not that big of a problem. What it is that their bones go black. They crumble. They die of an excruciating pain. These rare diseases, there's 8,000 of them. There's many diseases that even make you blind. And in fact, this also causes blindness. And so I've looked at this and I thought, well, okay, it's a protein. It's mutated in the body. Perhaps just like insulin, if that protein is not in there, perhaps we can make it. So we work with the Wellcome Trust. I got my designers on this. And again, mostly Muslims, we'll meet next. The black stuff is made from this metabolic pathway, this enzyme which causes this homogensetic acid not to be built, and that builds up in the body and causes the black precipitate, if you like. So what do we do? We worked up to midnight, and we did this within 6 months, which is a record. We got the human gene, we then inserted it into bacteria. The bacteria said, right, okay, I'll make it, then pulled it out, and then this is a midnight experiment. We saw whether it's active or not. You can make the protein, just like a scrambled egg. Is it scrambled? Does it look like an egg? And actually, it was hugely active. This curve tells you the activity. And it was a eureka moment. Okay, it works in vitro, in other words, it works in a test tube. But then we thought, hey, okay, we made it now. What do we do next? We test it in animals, but how do we do that? So we work with another university locally. We got the Wellcome Trust to give us money. And this is all documents, so you can Google all of this. And suddenly, it got rid of all the black stuff in the mice. So now it's a replacement therapy. The next step is to use humans. So this disease was the first ever disease identified as a genetic disease, one of the first ones, and we'd gone and done it in 6 months. So, and we're working on many of these other things as well, and these miracles can happen. And so we all encourage you guys, don't become an accountant, don't become all of these other things. I think they are important. This is what we should be doing. And, in some ways, yes, a lot of us go towards the doctors and I want to do this and that. We've got far too many doctors. We haven't got any scientists. In my field, in terms of Muslims, I've met probably 2 or 3. That's about it in this sort of sphere. The rest, we're enslaved in universities doing our little thing. But as scholars, if you look in Andalusia, what we were doing, we learned a whole range of things, interdisciplinary things. You've got to learn a bit of biology, a bit of physics, a bit of chemistry. Yeah? So, anyway, that's me with lots of photos, but the most important photo here is that left-hand one there. I got an Alumni Achievement Award from the University of Salford, working in health science. And that was my favorite award because the underdog, because this is not the greatest place of research, but, it's that stepping stones. Everybody can do things, it's just how to do it. And in my laboratories, I've taken undergraduates, I've taken students, I've taken school kids, I've inspired them, over 500 right now, and a lot of them have gone into industry. And, they're already making massive difference. So teams are important in innovation, ideas are important, but more than anything, I would say, and remember, this is where your power is, and this was my family and friends' power, and that is money. Money drives all of that, and some of these can be, this is what we need to accelerate things. Right now, we may have 500 masjids, alhamdulillah, in the UK. We may have 1,000. But do we have a center of inspiration in doing this kind of things? No. But in the past, there used to be. They used to be linked up, these madrasas. They had centers of knowledge. I've forgotten all of that. And we need to do that. So these are some other people, that's me. There's other people I work with as well in commercialization. This is my team at the bottom there. I take on students, so it's diverse. Diversity is great. That's when we started, that's when we expanded. These are people of great respect. Some are knighted as well. We work with all others. That's where we're based. That is the building that we're in, by the way. So I didn't know I was going to be in this building. So that's the Peel building. That's where everything started. And these are some of my collaborators that I work with. So I acknowledge all of those. And that's about it. Okay, thank you.